This is CPM Precalculus, Chapter 2, Number 22. So using a new set of axes, complete the following problems. Part A, graph y equals x cubed minus 3x and y equals x plus 2 cubed minus 3 times x minus 2 in contrasting colors. Label each graph with its corresponding equation. Okay, so here's my new axis, x-axis and y-axis. Okay. And I know the cubic function, that one alone looks like this, right? And I know a line looks something with -3 as a slope. It's going down, something like this. So I'm going to subtract these, and I'm going to get a new function. But I'm going to use my calculator as a tool to graph this. So I have x cubed minus 3x, right? I put that in the y equals here, and then I graph. Alright, so then I'm going to go ahead and graph this one in blue, y equals x cubed minus 3x. Okay, so where is it crossing things? Well, let me trace it. If I click trace, I get the x value here and the y value here, so I know at 0, 0 there's a point. Right here at 0, 0. I go all the way to the left. I go -1, comma 1.98, right? -1.7.17 is my y value, right? So I see, okay, so here's 1, 2, 3, 4, 5, 6. So I see it's crossing the x-axis again. There's an x-intercept between, it's around -1.8 something, so -1.8, right? So around right here, this is -1, -2, -3, -4, -5, and so on, right? I'm just using the values here. And it goes up to, I don't know, around 2, 1, 2, right? It gets up there around -1, right? Around here. I can even go ahead and do, in my menus, I can go ahead and, go to math. No, sorry, graph. I can do second, calculate, and get a value. So I could say at x is -1, what is my y value? At 2. So right there, right, -1, 2 is going to be my value. So from here, I'm just going to kind of sketch it. I can see it going down that way, up to here, down to here, right? Kind of looks like it does the same thing now on, let me trace again, on this side in quadrant 4, right? So it goes down 2, 1, 2, like this, right? Something like this. Let me just do it a little smoother. So this is my graph, right? I use the calculator as a tool. I know it's approximately between -1 and -2, closer to -2. Over here, again, between 1 and 2, closer to 2. Hits at 1, comma -2 is a point. -1, comma +2 is a point. And there's my graph. Okay, so let me put away the calculator. In another color, in green, I'm going to graph y is equal to x plus 2 cubed minus 3 times x plus 2. Okay, so if I look at this, I can see a difference between the two functions. This one, wherever there was an x here, there's an x plus 2 here. Again, an x here, right? And here, we have an x plus 2 here. So I know what that's doing. That's basically, if everywhere I see an x, I add 2. That's going to change the argument to be like f of x plus 2, which I know is going to shift the graph horizontally. Shift positive means to the left, 2 units. Okay, So I know this is basically going to look exactly like the one in blue, but every point is shifted to the left 2 units. So this point here is shifted to the left 1, 2 to be right here, right? This point here is shifted to the left 1, 2 to be right here. This point is going to be shifted to the left to be right here. This one's to the left 1, 2 to be right here, and so on, right? So I can even, before I even graph this, I'm going to graph it in my calculator again, but I know that it's basically going to look like this, okay? So it's the same thing shifted over 2 units to the left. So let's go ahead and graph this one. So I'm going to put in my calculator here. I'm going to clear that and put x plus 2 in parentheses cubed, so to the power of 3, minus 3 times x plus 2. Close my parentheses, click graph up here. Now I'm going to see that, yes, it's just what I drew in green here, right? Shifted over from blue to the left 2 units, okay? I can even put them both in my calculator in different y values. So y1 I'll leave as the green one, y2 I'll put as the blue one, which is x cubed minus 3x, graph that, and I'll see them both side by side, okay? So let me go ahead and label them. This one right here is, in green, is y equals x plus 2 cubed minus 3 times x plus 2. And in blue, I have y equals to x cubed minus 3x, okay? Because these are 2 different functions. I could even call this one y sub 2 and this one y sub 1, so they have different names, okay? And that's part A. So part B, I'm asked if x cubed minus 3x is equal to f of x, okay? So that's here, if our 1 in blue is equal to f of x. And then we want to write an expression for x plus 2 cubed minus 3x plus 2 in terms of f of x and call it g of x. So that's basically what I did here, right? I basically talked about that already, but let's do it again, okay? So if I know f of x is defined right here, then if I want to find what this is in terms of f, this is basically going to just be the input instead of x here, right? Here's an x in f of x. That means output is x cubed and 3x. So instead of x cubed, I have x plus 2 cubed. And instead of 3x, I have 3 times x plus 2. So that means my argument has to be x plus 2, okay? And if we want to call that g of x, then I would just say g of x is equal to f of x plus 2, okay? So I'm just using another name, g of x, and I'm defining it to be the function f with the input x plus 2, all right? So this is how I write the expression in terms of f, and then set it equal to a function called g, okay? So I could even say g of x is equal to f of x plus 2 is equal to x plus 2 cubed minus 3 times x plus 2. All right, so there's part B, and this ends CPM Precalculus Chapter 2, number 22.